Hi, we are Team Inspiration, a diverse team of 14 members ranging from 8th to 12th grade. My name is Eesh, and this is my co-speaker, Pahel.
Hello.
I am currently the RoboSub Deputy Captain, Electrical and Acoustic Lead.
And I'm currently the First Tech Challenge Captain and Computer Vision and Machine Learning Lead for RoboSub. So in this presentation, we're going to be talking about why we got into robotics and giving a little bit of team history about Team Inspiration and what we've been able to build throughout our seasons. And then we're going to be going into more details about what RoboSub is and how we took advantage of the new online format of RoboSub in order to be successful, and go over some challenges that we faced, and we'll end off with the future of STEM education. So personally, I started robotics when I was in 3rd grade, and during this time period, one interesting story is that my dad was trying to teach me what the circumference of a circle had to do with our move inch function, and I truly thought it was irrelevant until I got into the judging room and they asked me how our move inch function worked. And that's when I realized that all of the math that I'd been doing at 3 a.m, the night before the competition, was actually applicable. And that kind of led to my love for robotics, because I think that robotics definitely enables us to apply all of our knowledge, whether it's mathematical, just scientific, in a more practical sense, so we can see all of our knowledge come to fruition. And as our level of knowledge increases, so does our performance of the robot, which really keeps me going. And on top of that, I think that robotics has a huge scope for creativity, because we can pretty much create robots to do anything for us or program anything that we want to have done. And that's why I really like robotics.
Yeah, my story goes similarly with Pahel's. While I didn't have anything to do with staying up at 3 for math, I did start FLL, First Lego League, back in 3rd grade as well with a neighborhood team, and I've stuck to robotics ever since then. I've always thought of robotics as an extension of myself, and that's why it's always caught my interest. The ability to make things do things by themselves without me having to tell them, or it being another human being, inanimate objects doing animate things, is always just really interesting to me. And that's why I've stayed in robotics ever since then. So Team Inspiration started off in 2011 as a First Lego League team with 6 team members. Then, after a few years of First Lego League, in 2017 we started FTC, or First Tech Challenge. And ever since then, we have grown into a team of 14 members, ranging from 8th to 12th grade. We've gone to the World's Competition for First Tech Challenge 3 out of our 4 seasons, and we've won several Inspire Awards, which are considered the top awards in this competition. Then recently, last year, we started RoboSub in 2019. In our very first year in competing, we had already won the IEEE Innovation Award, the Most Inspirational Team Award, and now this year, we became the first place global overall winners of the competition. We're one of the first high school teams to ever win the overall first place rank in RoboSub's 23-year history. Over the course of its lifespan, Team Inspiration has accumulated over 50 awards in the past 9 years.
Team Inspiration does not only do robotics competitions, but also participates in a lot of outreach to benefit our community and communities around the globe. So in our first year of FTC, we mentored FLL teams, and FLL is a robotics competition where elementary through middle school students build Lego robots and compete in a robot game. And we were able to mentor these teams and also be coaches of these teams. And through this, we were able to create a sustainable STEM program for all of the schools that we had mentored FLL teams at. And we also hosted a scrimmage for 6 FLL teams that year. In 2017, we continued with all of our 2016 outreach, but we also partnered with First Global and started doing international outreach in Benin. And this was the first time we'd done international outreach. On top of that, we introduced robotics to the California State Games, which is a sports competition, and we presented an FRC robot to over 10,000 people. So FRC is just the next level above FTC and is only for high school students. On top of that, in 2017, we supported all major science fairs in San Diego and partnered with many organizations like the Fleet Science Center and Autism Speaks to teach different groups and demographics of children robotics. In 2018, we did all of our 2017 outreach, and we furthered our partnership with Benin, and also introduced a local FRC team to Team Benin, so they were able to have more mentors, and this was FRC Team Spider. And in 2019, we really ramped things up. We continued all of our previous outreach, created a 501c3 nonprofit to financially support sustainable STEM outreach efforts. And we also co-hosted Benin's first national robotics competition that year. And also we co-hosted a robotics competition in Paraguay. And in 2020, which is this year, we've continued all of our 2019 efforts and expanded to even more countries. This includes Togo, Indonesia, Bolivia, and other countries. And we've also collaborated with Porpoise Robotics to develop low-cost ROVs to help teach students. And on top of that, we have had multiple appearances in the news due to our success. So in conclusion, we've done over 320 outreach events and have affected over 131,000 students and parents.
To add on to what Pahel was saying, when we worked with a lot of countries such as Benin and Paraguay, we supplied a lot of their students and districts with STEM resources to encourage their students to participate in robotics. We traveled in person and hosted the competitions, and we sent several of these small robots known as M-bots. We also designed a competition with these M-bots for the students in Benin to use, and we met with the Benin US ambassador in accomplishment for our efforts. We also met the Chancellor and Dean of Engineering at the National University as Asuncion.
So, as you can see here on the screen, Team Inspiration has built many First Tech Challenge robots. And to go into more detail about FTC is a middle through high school robotics competition in which students build robots to complete challenges on the field, and these missions vary by season and theme. And while the robot game is one of the main aspects of FTC and teams are trying to get the most points possible, another huge aspect is outreach, which we described earlier. And this is how you would basically do outreach and have a successful robot to advance the world's competition. And as you can see, since 2016, our robots have gone more and more technically mature, including more sensors and a more stable drive base. So in 2016, we essentially built out of a kit, whereas this year and last year, we're able to build our chassis from scratch and have a more customized robot. And one thing which you can't see on the robot is the software, and throughout the seasons, our software has also gone more and more advanced.
RoboSub, the competition which we competed in this year, is an international student competition, meaning it's from teams all around the world, from India, Singapore, to here local teams, UCSD and Caltech. They design and build robotic submarines, otherwise known as AUVs, or autonomous underwater vehicles. These experimental AUVs mimic those of real-world systems in real-world scenarios, such as underwater exploration, seafloor mapping, and sonar localization. This way, students are able to come up to new ideas and solutions to current problems in the industry. We started off our first year of RoboSub by learning off a consumer AUV, namely the Blue ROV2 sold by Blue Robotics. We built off of its electronics and design to make our first custom AUV named Orange, namely for its 3D printed parts, which were the color orange. Orange had basic navigation and vision capabilities, but nothing more than that. We weren't able to complete all of the missions in the competition because we would need external sensors and more capabilities. With this in mind, and from what we learned off the design process in Orange, we made our latest AUV, Gray. Gray is equipped with multiple cameras, sonar, a Doppler velocity log for precise positioning, hydrophones, an acoustic modem, and several other sensors such as an IMU. All of these sensors and external capabilities help give us a more competitive edge against the other teams, which landed us at first place this year overall. We were graded in 3 parts: a technical paper, a team video, and a team website. Each one of these would highlight different parts of our robot and our team and show them to judges. Based off that, we were graded on our team journey, our lessons learned, the technical details of our ROV, and the other things that we encountered along our journey. In the final standings, we landed first place overall. We landed first place in our technical design report, and we also got first place in our website. We then got second place in our video.
As Eesh mentioned earlier, there were a lot of adaptations that the RoboSub committee had to make, and because of this, the competition was held online. And Team Inspiration recognized that we could make the most out of this situation, and this kind of enabled us to get first place overall, as Eesh mentioned earlier. So one thing that we recognized was that all RoboSub teams would have equal funding and equal resources. And because of this, the college teams, which previously had more resources like easier access to DVLs or more money, were no longer at an advantage. And because of this, we had more motivation and drive to do better in the competition. And because of this, we increased the amount of meetings that we could have. So previously, we met once or twice a week at the lab, but now we did not have to commute or anything like that. So we had bi-weekly meetings and daily meetings closer to the competition time frame. And we also had more sub-team meetings. And another thing we realized was that it would be easier to contact industry professionals because they didn't actually have to commute to work every day. And because of this, many industry professionals were more interested and had more time to work with us. On top of this, some things that we did technically were parallel prototyping. And we did a lot of parallel prototyping because a lot of team members were more inclined to develop models like CAD models before actually building the robot because of the limited number of interactions we could have. And another side effect of the online environment was that we had more time to innovate because obviously we had a lot less restrictions, especially at the time when schools were shut down. It was easier to learn complicated concepts like machine learning or using hydrophones because of the easy access we had to mentors and the amount of time that we were given. And another thing that Team Inspiration did to be successful was that we focused on the competition guidelines because there were only 3 aspects. There was the technical paper, the website, and the team video. And by only focusing on these 3 aspects rather than the nuances of the submarine that we were building, we were able to be more successful at competition because we only focused on things that were important to us. And on top of that, another side effect of the online environment was that we had a lot of heavy documentation because we need a lot of documentation to be able to, let's say, run tests properly or to pass on tasks to other team members because we couldn't meet in person to transfer these ideas. And because of that, we increased the amount of documentation we had, which in turn caused us to pay more attention to details of what we were doing. And some challenges we faced were that during the middle of the competition season, a lot of team members lacked motivation and drive. And this was just because we weren't able to see each other and see each other's progress. And in order to kind of face this, we had more meetings and we had more sub-team meetings, and this kind of allowed everyone to motivate each other. And another challenge was that it was difficult to carry out the actual technical work. And to combat this, we did a lot of remote software testing, and we did testing and prototyping at individual households. So because of this, we were able to write the software, push it out to our coach's house, and they were able to test the program without breaking any social distancing protocols. And whenever we had to test and prototype mechanical aspects, we did it from our individual households, and then we communicated our progress to the rest of the sub-team. And this kind of parallels larger companies that test and prototype at different locations or different countries. So that was an interesting experience. And one more thing that we did was that we introduced simulation software, which we could use for testing instead of having to test in person, just to see how well the code was working before we actually decided to go into the lab.
As far as the future of STEM education goes, Team Inspiration is really pushing to make it more affordable and accessible to everyone. We're working with local companies, as Pahel mentioned before, like Porpoise Robotics. It's a local startup nearby, and they're dedicated to creating an affordable AUV to help teach underwater robotics in schools. This AUV would encompass the mechanical, electrical, and programming aspects and design a curriculum around it, which then we could teach at local school districts and possibly go nationwide. This way students are exposed to STEM at an earlier age. Throughout this season, one of the main lessons we learned was that we have to learn to adapt to any situation. This pandemic was unprecedented for a time period, and at first we didn't know how to react. But after a while we learned to adapt, we got straight to work, and we used it to our advantage, used it to our benefit, regardless of whether it was or wasn't in the STEM field. Another thing is that the reason we push so hard to make STEM accessible for everyone all over the world is because we know firsthand that STEM can change lives. Nearly all of our parents, coaches, and mentors are immigrants who have successfully built their lives because of STEM. in the end, I would like to close by saying that STEM and robotics are not only something to learn, do, just like that, but it's also something to bond over, make friends with, become like a family. That's what our team has become over a course of maybe 4 or 5 years together. We've bonded really closely, we've spent so much time together that I would want to say that we're almost family now. Thank you.